greenhouse effect. So what is greenhouse effect? Is it a natural process or is it an artificial process? When we say from the perspective of greenhouse effect that is occurring on the earth, so usually greenhouse effect, it is a naturally occurring phenomena. Remember that. And we can also apply this same formula to in gardens or in flowering plants. So that's how we have some models called greenhouses. When you go to some parks or somewhere, so to use flowering and all those things, they will use greenhouses to keep that area warm. Okay, likewise. So usually that's how the name came, like greenhouse. Okay, greenhouse is a model that is used in gardens generally. Okay, you will have like a glass houses kind of thing. So they will call them as greenhouses like this. So usually they will use that to warm the temperature or warm the region. So here in greenhouse effect also what will happen means, usually there are certain gases which have the potential to trap the heat from the atmosphere and to keep the atmosphere warm. And those gases which has the ability to trap the heat or atmospheric heat are called as greenhouse gases. And these greenhouse gases, they will trap the heat and they will keep the earth warmer. They will keep the earth warmer. Okay, so we are calling them as greenhouse gases. And this process of trapping of the heat and subsequent making of the earth warmer, that process is nothing but greenhouse effect. And this is a naturally occurring phenomena. And because of this greenhouse effect, or due to this process only, Earth has become in one way as a habitable planet, or the planet which has the favorable conditions to live. This is one another condition which made the Earth as a living planet. Okay, so that is one thing. If without greenhouse effect, there would be, Earth might have become cooler, so we may not, or we might not expected the presence of life on the Earth in one way. So that is one another thing. So here, when we talk from the perspective of greenhouse gases, so can you able to recollect what are various greenhouse gases? Yes, carbon dioxide. Okay, carbon dioxide is one. Yes, good. Water vapor. Anyone from online? Yes, good. Nitrogen oxides. So under nitrogen oxides, can you able to recollect, is all nitrogen oxides have the ability to trap the heat? No? Okay, we have three nitrogen oxides: nitrous oxide, nitric oxide, that means nitrogen oxide, and nitrogen dioxide. Okay, now try to just take these three options: NO2, NO, and N2O. Now tell me which of them has the ability, which of them are greenhouse gases, or which have the NO2. Okay, how many of you say NO2? Okay, raise the hands otherwise, quickly. Take this time, don't worry. NO. Okay, we'll see. N2O, what about N2O? Okay, if you generally talk from the perspective of these three, only nitrous oxide, remember, only nitrous oxide has the ability to warm or trap the atmosphere. Okay, so nitrous oxide is the global warming gas, or it is the greenhouse gas, whereas nitric oxide or nitrogen dioxide both have the ability to cool the atmosphere. Okay, you remember that. And what is the process? You just go through, so that it takes a lot of time to explain on such things. But you remember these two, nitrogen oxides and nitric oxide, they have the ability to cool the atmosphere. Okay, so that is one thing, because they will release oxygen OH free radicals into atmosphere, and this oxygen free radicals, the hydroxyl free radicals which are released into atmosphere, have the ability to react with the methane, and they will reduce the methane levels. Are you getting that? Indirectly, what will happen? Both of them will release OH free radicals, hydroxyl free radicals into environment, and these hydroxyl free radicals, they will react with the methane and they will convert the methane into other forms. And here methane is another important greenhouse gas. So as this levels would be released indirectly, these two will cause global cooling rather than global warming. Remember that, but it doesn't have the ability likewise. So that is one another important thing that you have to keep in mind. And then, so other important gases. So can we say ozone? Does ozone is a greenhouse gas? Can it trap the heat? And what about the halogen compounds like, yes, CFCs, HFCs, HCFCs, or HBFCs? So all of them has the ability to cause the greenhouse global warming, or they have the potential to trap the heat. So that is one another important thing that you have to keep in mind. And apart from this, we also have some other things like perfluorocarbon, PF6. So we have perfluorocarbons, PFCs. Okay, PFCs, perfluorocarbons, or sulfur hexafluoride. Sulfur hexafluoride, 6 molecules of fluorine. So sulfur hexafluoride, perfluorocarbons, so they also have the ability to cause global warming, or they also have the ability to trap the heat. So these are some of the important greenhouse gases. Okay, now what about the black carbon, brown carbon? What is black carbon? What is the common name for black carbon? Soot. Soot is the common name for black carbon. That means when you burn the wood, then can you see some in the smoke, can you see some black aerosols that would be released? That is nothing but black carbon or soot. Okay, black carbon, soot. So all of them have the ability to cause the greenhouse effect. Okay, and now here, what is the process or how this greenhouse effect will occur? We have to understand this also. So generally, when we see from the perspective of the mechanism point of view, okay, so just assume this as the Earth's surface. Earth's surface, and we will have the sun rays that would be coming from the sun. So what do you call the radiation that is coming from the sun? Yes, so usually we can have solar radiation that is coming from the sun, and we will call that as insolation. Okay, or it is short form. So incoming solar radiation is nothing but insolation in short form. I'm writing in short form, and this is also one another name for that. And what is the wavelength in which insolation would be received? So usually when we talk from the atmosphere point of view, so usually atmosphere is transparent to incoming solar radiation, and it will be received in short wave length. So we will call them as short wave radiation. So insolation would be usually we will receive it in short wavelength, and usually atmosphere is transparent to short wavelength. Atmosphere is usually transparent to this. Can you able to understand that? Enough. We are saying that this is short wave radiation and insolation. So can you name common common short wavelength radiation which reaches the earth? Yes, one thing is, like you remember, UV radiation. This is one thing. And then visible light. So can you able to see the light which is coming? White light? So white light is a visible light. So visible light, UV radiation, these are some of the common examples for the short wave radiation. Okay, so atmosphere is transparent to this and we will receive the heat. And then what happens during this process? So during this process, earth warms up due to this radiation. And in other side, what will happen? Some amount of the sun rays that will be reflected back to the space. Okay, so the amount of light that is reflected back to the space without getting absorbed from the earth's surface is nothing but albedo. Okay, so you remember that. And sometimes what may happen, the albedo can also occur from the clouds also. So there would be some amount of that. So you live and forget about this. Now here we are concerned with only with this absorbed radiation, that is absorbed in short wave form. And the light that has been absorbed in the short wave radiation, that would be trapped by the surface of the earth and that would be released into the environment back during the night time. Okay, during the night time it would be released back into the space. Okay, so when it is released back, and sometimes what may happen, so some amount will be released back to space and some amount would be reflected back to earth's surface. Okay, so here this would be in generally long wave form, long wave radiation. This would be in long wave radiation. And what will happen? The greenhouse gases, they will trap this heat and they will keep the earth warm. Okay, because okay, so now you remember that earth's atmosphere is transparent to short wave radiation, so it will reach the earth and in one way it heats the earth's surface, and earth's atmosphere is opaque to the long wave radiation. So all the long wave radiation which is there, it would be trapped in the earth's atmosphere, so it heats the earth's atmosphere. So usually one of the common example for long wave radiation is the IR, so infrared radiation. So infrared radiation is a long wave radiation that would be reflected during the night time. Are you getting that? So this heat would be trapped and this heat will be responsible for keeping the earth warmer. So this is how the greenhouse gases will absorb the heat and they will keep the earth warmer. Okay, so here you remember this thing and you remember this thing and examples for this one, and what are the various gases that cause the greenhouse effect. So that is one thing. So these greenhouse gases has the ability to trap, and that process of continuous increase in the temperature of the atmosphere